Alright, welcome to your Intro to Biostats course. If I only sound half as dead as usual, it's because I have the flu, and so, I have to, live on purpose this time instead of by accident. So that basically just means that all of the sarcasm that you're going to see in this video is completely manual instead of, by coincidence. Anyhow, this video is probably going to be the least intense of the series. So if you decide to skip it, that's completely fine. But if you want to set a good baseline so that you can understand some of the more complicated stuff later, this is probably a good thing. This is probably a good thing to watch. All right. Now in biostats, you generally want to have a good understanding of numbers and equations. So let's just go through the dictionary together, okay? So first thing, we have variables, which is anything that we measure or manipulate in an experiment. Right, so an example of a variable is blood pressure. That's it's like a solid C tier variable. Another variable is post-exam depression. I'm sure a lot of you are very familiar with that one. And that indescribable feeling at 3 a.m. that you get when you're staring at the ceiling trying to fall asleep, and you start questioning every part of your life. That's right, it's another variable. And so a population is any entire group of people, so we can have the population of Uganda, so that's all of the people that live in Uganda, right? By contrast, the target population is the entire group of people that we're going to be studying. Okay, but if we look at Uganda, most of it is going to be rural areas. So if we make our target population hypertensive patients in Uganda, most of them So if we look at the population of hypertensive patients in Uganda, most of them are going to be in rural areas, which makes them kind of inaccessible. And so we might want to look at hypertensive patients in Uganda that are in a certain hospital instead, which would simplify things a little bit for us. And when we take something of the whole population, such as the average blood pressure of the population, or the average height of the population, the average weight, that's going to be a population parameter. But we're lazy and we don't want to do work if we can get away with it. So instead of looking at the whole population and measuring their blood pressures one by one, what we're going to do is we're going to take a sample, which is going to be, like a small percentage of the population, and we're just going to measure their blood pressures instead. And instead of finding a parameter, what we're going to do is we're going to find a statistic, which is essentially the same as a parameter, but it's only from the sample, right? So the average height of the population, that's a parameter. The average height of our sample, that's a statistic. And biostatistics is something that nerds do, right? Like, you don't really have to worry, you can read it right there if you want. And this is what sampling looks like over here. So we have our whole population, and what we're going to do is we're going to take a sample of them, and then this is our sample. Right? And so once we measure stuff from our sample, we can basically go, hey, this sample is supposed to represent our population, so generally speaking, the data that we got from this sample is probably going to be pretty similar than so generally the statistics of this sample is generally going to be pretty close to the parameter of the population. But as you can see, samples can vary, so we can have good samples, like this one, or we can have pretty bad samples, like these ones below. And that's actually one of the major parts of statistics, is you want to try and get as good of a sample as you can. And so, why do we learn biostatistics? Well, first off, it's funny to watch all of you suffer, right? Pretty straightforward. If you ask any of your seniors and you ask them to help in biostatistics, they'll probably laugh at you. And the second thing is that a large part of medicine is reading studies and then applying those studies in evidence-based medicine. And so having a good understanding of biostatistics isn't actually going to help you with either of those things, but it looks good when you talk with other doctors and you start talking about biostatistics stuff, and so it generally helps you in arguments. And back to the dictionary. So we have descriptive statistics, which is a summary or a description of all the data that you collect. And then there's inferential statistics, which is basically where you go, hey, I took a sample of 90 people that have ligma. and I gave them this medication that cured them of ligma. And there are 9,000 other people that have ligma. Wait, guys, I have a really, really good idea that we can do. And data is info and numbers. I don't know why I have to describe this. And what biostatisticians will be doing is they'll collect the data and then they'll analyze it to try and make it useful, right? And so where can you get all of this information? Well, you can get it from studies, and you can also get it from government websites and health organizations. Now you can get it from other sources, but let's be real, none of them matter. And back to your dictionary. So a system is a group of components that work together. And these systems can have human parts and non-human parts. So if we look at a hospital, for example, it'll have the machines and it'll have the doctors and nurses. Right, so it has humans and non-human parts. And in systems thinking, we try to look at the system as a whole, rather than each of the individual parts. Whereas in statistics, we'll generally try to look at individual parts of the system instead. Now, a fallacy is just a really fancy schmancy term for when you misuse statistics. Right, so I'll probably have like a linked video somewhere, right, like either up in this corner or that corner or down in the description or comments, doesn't matter. But, you know, if you like are interested for whatever reason, you can look at to learn more about, you know, misusing statistics. But generally speaking, when statistics are misused, it can be very costly, right? For example, you have many court cases where statistics were used, but they weren't used properly. And this led to many convictions of innocent people. So, models are any simplification of the world that will try to describe something in the system. And they have many types. Now, if you're an engineering student, which, why are you here? Go away. You might use a physical or a mechanical model. But otherwise, you're probably going to be using mathematical models, such as deterministic and probabilistic models. Right, now there are also other models, but let's be honest, none of us care about them. They don't matter. And, you know, they're about as insignificant as looking at the sunrise to measure the exact angle of the sun every morning. Back to your dictionary, let's go. So there are three modes that you can use to represent data. The first one is the mode itself, which is the most common value. Then you have the median, which is the middle value of the ones if you list them in ascending order. And then you have the mean, which is the calculated average. Now these can be very different, but all of them are valid and they can mean different things. Right, so first off, let's take this example, which I definitely didn't steal from anywhere. Don't check, do not fact check me, please. So, let's take the grades of a midterm, right, and the pass here is 60. So if you take the mean, it has a pass average. But if you take the median or the mode, then the group has a fail average. So which average would you use to represent this group? Now obviously you guys would try to use the fail average so you could get a curve up, right, like, obviously. While the doctors would try to get a pass average because they're lazy and they don't want to give you a curve. Let's be real. But you know, as you can see, these averages can mean very different things, right? And we'll go back to these averages later on and we'll describe them in further detail. But it's just to have a good idea. It's like a good thing to have a good idea of these averages for now. Now here's another way you can mess around with data. So you can change the way that you present the data. So as you can see, these two graphs represent the same thing. But this one on the right here looks a lot more significant than the one on the left. Why? Because we zoomed in. And so just like that, you can make any change in data look a lot bigger than it actually is, just by changing the scales that you're using. And for your final episode of the dictionary for today, we have epidemiology. And so that's basically where we look at health-related stuff in relation to a population. So this could be the distribution and frequency of a disease, and determinants and control measures that affect the disease. And so what we try to do is we try to study diseases, and we try to look at external factors that might cause this injury. You can think back to your previous courses on community medicine if you want. I won't say exactly which one, but I think you know what I'm talking about. And distribution and determination, those are the two key things when it comes to epidemiology. And so distribution is where we look at the patterns of the disease and its relation to certain factors, while determination is where we look at cause and effect. Okay? So, that's all for today. I'd say like and subscribe, but I don't actually care what you want. Get out of here.